Hello everyone, my name is Bino, and in this video we'll be determining the following integrals using the method of partial fractions decomposition. We use this method when we have an integral of f of x divided by g of x dx, and the f of x and the g of x are both polynomials, and the degree of the f of x is less than the degree of the polynomial g of x. For our first question, we integrate 4x plus 5 divided by x minus 1 multiplied by x plus 2 dx, and as we can see in the denominator we have unique linear factors, as the x minus 1 is different from the x plus 2. Suppose we had f of x divided by x plus b multiplied by x minus a, then our decomposition will be equal to a divided by x plus b, the first factor, plus b divided by x minus a, the second factor. So in our case, we have 4x plus 5 divided by x minus 1 multiplied by x plus 2. Then the decomposition will be equal to a divided by x minus 1 plus b divided by x plus 2. And we have to solve for the numerical values of a and b. We start by multiplying the whole equation by the denominator on the left, the x minus 1 multiplied by the x plus 2. So we have 4x plus 5, which we multiply by the denominator on the left, the x minus 1 multiplied by the x plus 2. This is still divided by x minus 1 multiplied by the x plus 2. Even on the right hand side, we are going to multiply by the denominator on the left, x minus 1 multiplied by x plus 2. What we do on the left, you also do on the right, and this is still divided by the x minus 1 plus b also multiplied by x minus 1 into x plus 2 divided by x plus 2, and that x plus 2 and that x plus 2 will cancel out each other, and the x minus 1 and that x minus 1 will cancel also. The x plus 2 and the x plus 2 will cancel, including that x minus 1 and that x minus 1. So on the left hand side, we are left with 4x plus 5, which will be equal to a into x plus 2 plus b into x minus 1 We start by determining the value of a by letting x strategically to be equals to 1, because you can see 1 minus 1 will be equals to 0, and 0 multiplied by b will be equals to 0, giving us a window of opportunity to determine the value of a. So x will be equals to 1, 4 by 1 will be equals to 4, plus 5, and this will be equals to a into, where there is x, we substitute 1 plus 2 plus b into 1 minus 1. 4 plus 5 is equals to 9, and this will be equals to a into 1 plus 2, which is equals to 3. That 1 minus 1, like I said, will be 0, and 0 by b will be equals to 0. So 9 will be equals to a multiplied by 3. We divide both sides of the equation by 3, as that 3 and that 3 will cancel out, and a will be equals to 9 divided by 3, which is equals to 3. On the other side, we determine the numerical value of b by strategically letting x to be equals to negative 2. As we can see, negative 2 plus 2 will be equals to 0, and the 0 multiplied by that a will be equals to 0, giving us a chance to determine the value of b. We are going to let x to be equals to negative 2. So 4 into negative 2 plus 5, this will be equals to a into negative 2 plus 2 plus b into negative 2 minus 1. 4 multiplied by negative 2 will be equals to negative 8 plus 5, which is equals to negative 2 plus 2 will be equals to 0. 0 multiplied by a will be 0, and we'll be left with b into negative 2 minus 1, which is equals to negative 3. And the negative 8 plus 5 will be equals to negative 3. And the negative 3 will be equals to negative 3b. We divide both sides of the equation by the negative 3. And that negative 3 and that negative 3 will be equals to 1. And even on the left hand side, the negative divided by that negative will be equals to positive 1. Integrating the left hand side with respect to x is just the same as integrating the right hand side with respect to x, but it will be much easier for us to integrate the right hand side. So we have the integral of a, which we determined as positive 3 divided by x minus 1 plus b divided by x plus 2, but we determined b as 1 dx. This will be equals to, so we distribute the integral and the dx inside the parentheses. So we have the integral of 3 divided by x minus 1 dx. We can push the 3 out of the integral since it don't affect the integration process. We have plus the integral of 1 divided by x plus 2 dx, and this will be equal to 3 multiplied by the integral of 1 over x minus 1, which is ln of x minus 1, plus the integral of 1 divided by x plus 2, which is ln of x plus 2 plus c. We now have to evaluate the integral of x plus 2 divided by x minus 1 squared dx, and in the denominator we have repeated linear factors where the x minus 1 squared is equals to x minus 1 multiplied by x minus 1. So the x minus 1 is repeating itself twice. Suppose we had a function f of x which has a lower power than the denominator, f of x divided by x minus a squared, then the decomposition will be equals to a divided by x minus a plus b divided by x minus a squared. Suppose we had x minus a raised to the power 3, then the decomposition will include c divided by x minus a raised to the power 3. Suppose we had x minus a raised to the power 4. The decomposition will include d divided by x minus a to the power 4. In our case, we have x plus 2 divided by, so we forget about the integral for now. This is divided by x minus 1 squared, and the decomposition will be a divided by x minus 1 plus b divided by x minus 1 squared. So we have to determine the numerical values of a and b. So we multiply both sides of the equation by the denominator on the left, the x plus 2. We multiply it by the denominator on the left, the x minus 1 squared, and the left hand side is still divided by the x minus 1 squared. What we do on the left, we do on the right. So we multiply the right hand side with x minus 1 squared. The a was divided by x minus 1 plus b multiplied also by the x minus 1 squared, and the b is still divided by the x minus 1 squared. And that x minus 1 squared will cancel out with that x minus 1 squared, and that x minus 1 squared also cancels out. We have x minus 1 cancelling out with one of the x minus 1, and on the left hand side we are left with x plus 2, and on the right hand side we have a into x minus 1 plus b we start by determining the numerical value of b by letting x strategically to be equals to 1, because you can see 1 minus 1 will be 0, and 0 multiplied by that a will be 0. This will give us an opportunity to determine b. So we let x to be equals to 1. Where there is x, we substitute 1. Even on the right hand side where there is x, we substitute the 1. 1 plus 2 is equals to 3. 1 minus 1 will be equals to 0, and 0 multiplied by a will be 0, so our b will be equals to 3. Now we determine the value of a. We have our equation as x plus 2 is equals to a into x minus 1 plus b, but we have b as 3. Now we can let x to be equals to any number, but let's choose a smaller number, such as 0. So where there is x, we substitute 0. This will be equals to a into 0 minus 1 plus 3. On the left hand side we have 2 is equals to a into negative 1 plus 3. We take the 3 to the left, where it's going to change sign to negative 3 plus 2. This will be equals to a into negative 1, which is equals to negative a. You have negative 1 on the left, which is equals to negative a. So our a will be equals to 1 after we divide both sides of the equation by negative 1. So we determine the value of b as 3 and the value of a as positive 1. The integral on the left hand side will be equal to the integral on the right, but it will be much easier for us to integrate the right hand side. So we have the integral of a, which is now equals to 1, divided by the x minus 1 plus b, which is now equals to 3. We determined it as 3 divided by x minus 1 raised to the power 2 dx. We distribute the integral sign and the dx inside the parentheses. So we have 1 divided by x minus 1 dx plus the 3 will not affect the integration process. We take it out of the integral and we have the integral of 1 divided by x minus 1 squared dx. The integral of 1 divided by x minus 1 dx will be ln of x minus 1. So we determine the integral of 1 divided by x minus 1 squared. So we forget about the 3 for now. We let u to be equals to x minus 1 and the derivative of the u with respect to x. The derivative of that x will be equals to 1. The derivative of the negative 1 will be 0. 0 plus 1 is equals to 1. Our du over dx, we multiply both sides of the equation by the dx. And that dx will cancel out such that du will be equals to dx. We have the integral of 1 divided by x minus 1. So in the place of that x minus 1, we substitute u. The x minus 1 is squared, so even the u will be squared. And in the place of the dx, we substitute the du because they are equal. Du is equals to dx. We have the integral of 1 divided by u squared du, and we express 1 over u squared as u to the power negative 2. And the integral of u to the power negative 2 with respect to u will be equals to u to the power negative 2 plus 1 divided by negative 2 plus 1 plus c. Negative 2 plus 1 is equals to negative 1. This will be divided by negative 1 plus c. So we have negative u raised to the power negative 1 plus c. We further express u to the power negative 1 as 1 divided by u. And in the place of u, we go and substitute back the x minus 1. So our u, we let it to be equals to x minus 1 plus c. So we have our integral as negative 1 divided by x minus 1 plus c. So let's not forget the 3. And we determine this integral as negative 1 divided by x minus 1. The 3 multiplied by c, we can call it the c1. Our integral in full will be equals to the ln of x minus 1 minus 3 divided by. For this last question, we have to evaluate the integral of 7x plus 5 divided by x plus 1 multiplied by x squared plus 1. We have a combination of two factors, the first one being a linear factor, the x plus 1, and we also have an irreducible quadratic factor, the x squared plus 1, since we cannot factorize it any further. So the decomposition will be different from the previous ones. So we have 7x plus 5 divided by x plus 1 multiplied by the x squared plus 1. This will be equals to a divided by the linear factor, the x plus 1, And for the x squared plus 1, the irreducible quadratic factor, for the x squared plus 1, we have to include mx plus c, the linear mx plus c, as part of the numerator. But in order for us to keep consistent with our lettering, we can replace m with the letter b. So we have to solve for the numerical values of a, b, and c. We will multiply both sides of the equation by the denominator on the left hand side. The 7x plus 5 will be multiplied by x plus 1 multiplied by the x squared plus 1 divided by the x plus 1 multiplied by the x squared plus 1. So even on the right hand side, we also multiply the right hand side with the x plus 1 multiplied by the x squared plus 1. Multiply this by the denominator on the left hand side, the x plus 1 multiplied by the x squared plus 1. So on the left hand side, that x squared plus 1 and that x squared plus 1 will cancel out, and the x plus 1 and the x plus 1 will also cancel out, and we'll be left with 7x plus 5, which will be equals to a, and we distribute the x plus 1 and the x squared plus 1 inside the parentheses. So this will be equals to a into x plus 1 multiplied by the x squared plus 1, and this is still divided by x plus 1 plus bx plus c also multiplied by x plus 1 multiplied by the x squared plus 1, and we are dividing this by the x squared plus 1. So the x squared plus 1 and that x squared plus 1 will cancel out, and that x plus 1 and that x plus 1 will also cancel out, and the 7x plus 5 will be equals to a multiplied by the x squared plus 1 plus bx plus c, which will be multiplied by x plus 1. So we start by determining the value of a by strategically letting x to be equals to -1. When you substitute that -1 plus 1 will be 0, and 0 multiplied by bx plus c will be equals to 0. So where there is x, we substitute -1, and we'll have 7 into -1 plus 5, which will be equals to a into -1 squared will be equals to 1 plus 1 plus b multiplied by -1 will be equals to -b plus c, -1 for x plus 1. So 7 multiplied by -1 will be equals to -7 plus 5, a into 1 plus 1, which is equals to 2, and the -b plus c will be nullified by the -1 plus 1, which is equals to 0, and -7 plus 5 will be equal to -2, which is equals to a multiplied by 2, we divide both sides of the equation by positive 2, and the value of our a will be equals to, so that 2 and that 2 will cancel out, and a will be equals to negative 2 divided by 2, which is equals to negative 1. We copy and paste our chief equation, and we already determined the value of a as negative 1, so we substitute negative 1 where there is a, and now we determine the value of c by strategically letting x to be equals to 0. 0 multiplied by the b will be equals to 0, and this will give us an opportunity to determine the value of c. So we let x to be equals to 0, and the 7 multiplied by 0 will be equals to 0, and we'll be left with 5 on the left hand side, which is equals to negative into 0 squared will be 0, and we'll be left with the 1 plus 0 multiplied by b plus c into 0 plus 1. We take the negative 1 to the left, and it's going to change sign to positive 1. 0 multiplied by the b will be equals to 0 plus c into 0 plus 1. So c will be equals to 5 plus 1, which is equals to 6. So we have determined the value of c, and we paste our equation. We already determined a as negative 1, and now we have determined the value of c as positive 6. Now we have to find the value of b by letting x to be equals to any number. So in this case, the smallest number that we can use will be equals to 1. 7 multiplied by 1 will be equals to 7 plus 5, which is equals to negative, into 1 squared, which is equals to 1 plus 1, plus b multiplied by 1, which will be b, plus 6 into 1 for x plus 1. 7 plus 5 is equals to 12, which will be equals to negative into 1 plus 1, which is 2, plus b plus c multiplied by 1 plus 1, which is equals to, we have 12, and we take the negative 2 to the left, it becomes positive 2, which is equals to b plus c multiplied by the 2. 12 plus 2 will be equals to 14, and this is equals to b plus 6 multiplied by 2. We divide both sides of the equation by positive 2, and the 2 divided by 2 will be equals to 1, and we'll be left with b plus 6 on the right hand side, and on the left hand side we have 7, and we take the 6 to the left, and b will be equals to 7 minus 6, which is equals to 1. So we determined the value of b as positive 1. So integrating the left hand side will just be the same as integrating the right hand side, but it will be much easier for us to integrate the right hand side. So we have the integral of a divided by x plus 1, but our a we determine as negative 1 divided by x plus 1, and we had plus bx plus c, and our b was equals to 1, and our c was equals to 6, and this is divided by the irreducible quadratic factor, the x squared plus 1. So let's break. We break the x plus 6 divided by x squared plus 1 as x divided by x squared plus 1 plus 6 divided by the x squared plus 1 dx. We distribute the integral sign and the dx inside the parentheses. This will be equal to the integral of negative 1 divided by x plus 1. But we push the negative out of the integral and we'll be left with 1 divided by x plus 1 dx, plus we take the integral of 6 divided by x squared plus 1, and we also push the 6 out of the integral, and we include the x divided by the x squared plus 1 dx. The integral of 1 divided by x plus 1 will be equals to ln of x plus 1, and the integral of 1 divided by x squared plus 1 will be equals to the arctan of x, and we have to determine the integral of x divided by x squared plus 1. The integral of x divided by x squared plus 1 will be determined using the u substitution method, where we let u to be equals to the x squared plus 1. We differentiate the u with respect to x. The derivative of the x squared will be equals to 2x, and the derivative of the 1 will be equals to 0. We multiply both sides of the equation by dx, so du will be equals to 2x dx. Let's rearrange our integral as 1 divided by x squared plus 1 multiplied by the x dx. We have x dx and that x dx, so let's divide both sides of the equation by the 2, and du divided by 2 will be equal to x dx. So in the place of that x dx, we'll substitute du over 2, because we can see that du over 2 is equal to x dx. We have the integral of 1 divided by the x squared plus 1, but we substitute u where there is x squared plus 1, and x dx is equal to du divided by 2, which is equal to, so we push the 1 over 2 out of the integral and we'll be left with 1 divided by u multiplied by du inside the integral, and this will be equal to 1 over 2 multiplied by the integral of 1 over u, which is ln of u plus c. This will be equal to 1 over 2 multiplied by the ln of, in the place of u, we substitute back the x squared plus 1 plus c. So we determined the integral of x divided by x squared plus 1 dx as 1 over 2 multiplied by the ln of x squared plus 1 plus our constant c. If you have any questions, you can drop them in the comment section below. Remember to subscribe, like, and share this YouTube channel with your fellow mates.